Okay, I hope I'm audible. So we'll start the class today. Uh, so welcome to the problem solving and doubt clarification class for wastewater treatment and recycling. We are in week 3, and in this week 3 we have learned about the wastewater characteristics. That is, we learned about many of the quality parameters. So we have seen that there are various type of quality parameters starting from physical, chemical, and biological parameters. So these are all the parameters that we have learned in this week 3, which are listed here. So can someone tell me few of the biological quality parameters? Which of these are few of the biological parameters? I hope you have gone through the lectures. You can write in the chat box also. Am I audible? Can someone please confirm?
Yes, sir.
Yeah. So my question is, which of these is a biological parameter? Just name one. You can use the chat box. I hope others are also listening to me.
BOD.
Okay.
Fecal coliform,
Yes, exactly. Fecal coliform is a
nu-
biological parameter. Okay.
nutrients,
So,
and
and what about physical parameters? Name some physical parameters.
pH, temperature,
pH, temperature,
color,
color. Okay. Okay.
turbidity,
Can someone tell me the unit for turbidity? Unit of measurement of
NTU.
turbidity. NTU. Okay. What is the full form of NTU?
Nephelometry turbidity unit.
Yes, exactly. Okay, so I hope you have gone through the lectures. So I have prepared some 20 questions. So first we will start with some theoretical questions. All will be MCQs. So first we'll start with some theoretical questions and the second half will be totally numerical. So just wait for a bit. We will have numerical questions too. Okay, so here is the first question. So the first question is, I think I already asked, but still okay. Which of the following is a biological water quality parameter? So we have suspended solids, we have dissolved oxygen, we have chloride, and we have none of the above. So which of the following is a biological water quality parameter?
none of the above.
None of the above. Okay. Anybody else? DO. Okay. D'Souza is telling it's DO.
It's BO.
DO. Okay, so just think closely. Is DO a biological parameter or a chemical parameter? So we will see the answer. So the answer is, as Saket told, it's none of the above because if you see, suspended solid is a physical water quality parameter, whereas DO and chloride contents are chemical water parameters. Okay, so the yes, it involves the lives of fishes in it, but it is a chemical parameter. If you see exclusively a biological parameter, then fecal coliform. If we talk about fecal, different types of microorganisms that are present in the uh, wastewater system or the water system, these are the biological parameters. So we use fecal coliform as an indicator of the like how much of infectious microorganisms are present in the system. So the correct answer is D, none of the above. Okay, so the next question. Apparent color in water sample is caused by suspended matter, dissolved matter, colloidal matter, both B and C. So what do you think? Apparent color. We have learned about the quality parameter color. So first of all, tell me what are the two types of colors that can be present? One is apparent color. What is the other one?
Apparent color and true color.
True color. Okay. So now tell me what is the correct answer? Like apparent color is caused by which of the following matter? Others, you can use the chat box. If you participate, it would be better. Okay.
Maybe colloidal matter.
Colloidal matter. Okay. Someone is telling colloidal matter. Other person is telling it's dissolved matter. Okay, we'll see the answer. I think it's none of them. So apparent color is produced by the suspended solids because because the dissolved solids and the colloidal matter and the dissolved matter gives the true color of the solution because they're easily dissolved in the system. So once it is dissolved in the system, it gives the true color of the system. Whereas apparent color, which is like uh, due to the suspended matter, because it's not the true color, it looks like it will give the color, but it is not the true color of the system. It will give an apparent color. So suspended matter is the correct answer. So I can memorize it by like which dissolves easily gives the true color. Okay, I hope I am clear. So we'll move on to the next question. A combination of 1 milligram per liter of platinum and zero point 0.5 milligram per liter of cobalt is used as a standard one unit of conductivity, pH, color, temperature. Again, it's a question related to the parameter color. So, which of the following parameters requires the use of platinum and cobalt?
C.
Okay, Anil Kumar is saying it's C. So, yeah, it's the right answer. C, color. So we need 1 milligram per liter of platinum and zero point 0.5 milligram per liter of cobalt as the standard unit of current. Okay. Okay. The next question. Sulfates and chlorides of magnesium in water will result in A. Algal blooms, permanent hardness, eutrophication, or water softening. So if my water contains magnesium sulfate or magnesium chloride, then which of the following thing is likely to happen?
Permanent hardness.
Permanent hardness. Okay. Anyone else? B. Okay. This is also saying it says B.
Permanent hardness.
Permanent hardness. So it's an unanimous answer. So permanent hardness is the right answer. So what is the other type of hardness that is present in water?
Temporary hardness is a calcium and magnesium also is there.
Okay, but when do we see it's a temporary hardness? It the cation can be calcium or magnesium. It can be true for permanent hardness also for temporary hardness also. But but how we will come to know whether it's a temporary hardness or a permanent hardness? What is the okay? Yes, temporary is by the presence of bicarbonates or carbonates. So by the presence of this, we can find out it's a temporary hardness. And temporary hardness can also be removed just by boiling. Okay, so with the help of boiling, we can remove the temporary hardness of the water. Okay, so we'll move on to the next question. The question is identify the correct statement regarding turbidity of a water sample. Turbidity in water ensures a better disinfection process during the water treatment. The intensity of light transmitted through the water is measured in a nephelometer to estimate the turbidity of a sample. Non-settlable fine suspended particles cause turbidity in water and all of the above. So which of the statement is true?
Non-settlable fine suspended particles cause turbidity in water.
Okay. Anyone else would like to try? Saket is saying it's a C. D. All of the above. Okay. Okay, so we'll go first by statement by statement. The first statement says that turbidity in water ensures a better disinfection. So what do you really think? Because of turbidity, it would be easier to disinfect or not? If my wastewater has turbidity, so if I am using some disinfection method through ozone or through any chemicals, so will it be easier for disinfection or not? Just give me yes no answer. No need to explain.
No.
No, yes, because this turbidity uh, causing particles, which are the settleable solids or the non-settleable solids, it will protect the organisms from getting disinfected. So it makes it difficult to disinfect. Okay, so the next question is the intensity of light transmitted through the water is measured by nephelometer. So what would be the correct answer for this if it's not true?
90 डिग्री रिफ्लेक्शन होता है उसमें.
Yes. We in nephelometer we use the 90-degree reflected particles. Okay, so both A and B are incorrect. C is correct. We'll see the answer. Yes, C is the correct answer. Okay, so detailed solution also speaks about the same thing which I have said. So C is only the correct statement. I hope it's clear for others because only Saket is replying. Others, please, if you have any concerns or any query regarding these questions or anything in general with this topic, you can ask me whenever you want. You can just switch on your mic and speak. Okay, there is no problem. Okay, so the next question: which of the following causes acidity in water sample? So we have carbonic acid, bicarbonate ion, hydrogen cation, all of the above. Which of them causes acidity? So we have learnt about acidity and alkalinity. Here it is asking about acidity. It's a pretty simple question. No one? You can use the chat box. C. Okay.
कार्बोनिक एसिड.
Okay. What about the bicarbonate ion? Will it not impart any acidity to the system? From this also one of the proton can be separated. Okay. So if H plus is the answer, then both bicarbonate and carbonic acid can also impart acidity to the system. Am I clear? Because if we dissociate, we can also get protons, one proton from bicarbonate. So it will become as H plus H CO3 2 minus, and also another and two more protons from carbonic acid. Okay, so all these three imparts acidity to the water sample. Okay, so the next question is alkalinity in water sample is expressed in terms of H2CO3, HCO3 minus, CaCO3, or OH minus. Please read the question carefully. It is asking alkalinity in water samples is expressed. Here I am not asking about which of these impart alkalinity. I am asking what is the unit, kind of like in what terms we express alkalinity.
कैल्शियम कार्बोनेट.
So yes, calcium carbonate is the right answer because OH will impart alkalinity. Other things can also impart alkalinity, but I am asking about which of what is the like measurement which in which we in terms of express the parameter. Okay, so the next question: titration with standard acid to an endpoint of 8.3 pH is called
Caustic alkalinity.
caustic alkalinity. Okay, no, CaCO3 is not used to determine the hardness. It is expressed in terms of hardness. It is expressed in terms of CaCO3. Okay, so just wait for a minute. We have some numericals where you will understand like how alkalinity or acidity is expressed in terms of CaCO3. Okay, just wait for some time. I have a few numericals and it will give you a clear picture of the concept. Okay, just wait for it. So here, uh, up to 8.3 pH, it's a pretty simple question. So it is caustic alkalinity. And can someone tell me what is the other name of caustic alkalinity?
Phenolphthalein alkanities, sir.
Phenolphthalein alkalinity, yes. So phenolphthalein alkalinity is the other name of caustic alkalinity. Okay. So next question is algal blooms caused by excess nitrogen and phosphorus in aquatic ecosystems result in decrease in dissolved oxygen, production of elevated toxins, high bacterial growth, all of the above. So if we have algal blooms in our ponds or lakes anywhere, so which of the following things can happen in the system? Others, you can also participate, please.
All of the above.
All of the above. Okay, so can someone tell me how algal bloom will decrease the dissolved oxygen? How it will decrease the dissolved oxygen? What do you think? Will algae consume the dissolved oxygen, or how it will decrease the dissolved oxygen? Anybody has any idea you would like to try? Have you ever seen an algal bloom?
It will consume oxygen in photosynthesis.
So in photosynthesis, oxygen is consumed or released. Okay, so I will clear the confusion. If algal bloom is present, if you might have seen the greenish layer over the ponds or lakes. Okay, so there is a greenish mat which is present over the lakes or pond, and we know with the help of like phase transfer from gaseous phase to liquid phase, the dissolved oxygen gets into the system due to phase transfer. So suppose if there is a greenish mat of algae over the top layer of the pond, whether the phase transfer will happen easily? It will not. Okay, so the phase transfer will not happen from the atmosphere into the pond system. Okay, and also there are many bacteria present in the ponds, so they will consume this oxygen. So ultimately there is no phase transfer, like there is no dissolved oxygen that is coming outside from the system, but inside the system oxygen is getting consumed by the bacteria.
Means reoxygenated stopped.
Yes, yes, yes. So because of this, there will be decrease in the oxygen level, and also because of algal blooms, there will be elevated toxins and high bacterial growth. And we also, you might have learned about the symbiotic relationship between algae and bacteria. So if they both are present in the system, there is a symbiotic relationship. So there will be a high bacterial growth also. So D is the correct answer. Okay. So this is the answer, and we'll move on to the next question. So this is the first numerical, like what is the theoretical oxygen demand of 300 milligram per liter of glucose? I hope you everyone knows the formula of glucose. So you have to find the theoretical oxygen demand of 300 milligram per liter of glucose. So what is glucose? Anyone?
C6H12O6.
C6H12O6, pretty simple. So you just have to write the balanced chemical equation, like how much of oxygen will be required to transform glucose into CO2 and H2O. You just write the formula, balance it, and then with further calculations, you can find the theoretical oxygen demand. It's a very simple question. I hope you have your pen and paper with you. If you don't have, please bring one, because there are many numerical questions up after this question. So please be prepared with your pen and paper. It will be helpful for you because I have many numerical questions after this. I'll wait for 2 minutes. Those who have joined now, I have this numerical question. Please,
320.
320. Okay. So I have this numerical questions. If you want to try, please get your pen and paper so that you can work out the numerical and tell me the answer. Okay, so Saket has said it's 320. We'll check the answer. So answer is 320. Yes, it's correct. So here is the detailed solution. So we have C6H12O6, which is glucose. It will require 6 moles of oxygen. Okay, so as per the balanced chemical equation, it will require 6 moles of oxygen. So we can see if we go by the molecular weight of glucose and the total oxygen that is required. So molecular weight of glucose is 180 grams. So 6 into 12 plus 12 into 1 plus 6 into 16. So it will give you 180, and 6 into 32 will give you 192 gram of oxygen. So for 180 gram of glucose, we will require 192 gram of oxygen. So for the requirement of 300 milligram per liter of glucose, we will require 192 by 180 into 300. That is 320 milligram per liter. Okay. I hope it was a very simple numerical. Okay. So the next question. If you have any doubt regarding the previous question, please let me know. Okay. Okay. So the question is, the wastewater sample of 2 milliliter is made up to 300 milliliter in a BOD bottle with distilled water. The initial day of the sample is 8, and after 5 days it becomes 2 milligram per liter. So what is the BOD? It's a very simple question. Please try it out. Others also, please try to involve yourself. So the DO level is decreasing from 8 to 2 after 5 days, and we have 2 ml of the sample in 300 milliliter of BOD water. So what is the BOD? I think the okay. I think the options here are incorrect. I think that there is some typo error.
Yes, yes.
Ha, okay, yeah. 900 is the correct answer. There is some typo error.
That is
This,
right answer.
yeah, yeah. Okay, so BOD will be directly equal to the DO initial minus DO final into the dilution factor. So we have 8 minus 2 into 300 by 2. So in 300 ml, we have 2 milliliter of sample. So it will be 900. I think there is some typo error in this. So I hope everyone is clear with this. It will be 900 milligram per liter. Okay. Okay. So the next question is, the concentration of OH minus ion in wastewater sample is measured at 17 milligram per liter at 25 degrees Celsius. What is the pH of the water sample? 11, 3, 12, 7. Where we are asking the pH of the water sample, and the OH minus concentration is given, which is measured at 17 milligram per liter. So what is the formula for pH? Can anyone tell me what is the formula for pH? I would appreciate if someone else gives me the answer. What is the formula for pH? Okay, yes, negative logarithm of H plus concentration. So you have been given the concentration of OH minus ions. Should I tell you the solution or anyone is trying? Anyone with the answer? Or should I go into the solution?
Sorry, sir.
Okay, wait. Okay, I will. So the correct answer is 11. Let's see how it comes. So first of all, we know pH is the negative logarithm of H plus ion concentration. So first we have to find out what is the H plus ion concentration. Okay, so we also know that if you multiply H plus ion concentration and OH minus ion concentration, it will lead up to 10 raised to power minus 14. Okay, this we know. This is a fact. So here we know that 1 mole of OH minus ion will be equal to 17 grams because O is 16, H is 1. So 1 mole of OH minus ion will be equal to 17 grams. But we have been given that OH minus ion concentration is 17 milligram per liter. So if it's in milligram per liter, so it will be 10 raised to power minus 3 mole. Is it clear? So 1 divided by 1000. We are changing gram to milligram. So 1 divided by 1000. So instead of 1 mole, it will be 10 raised to power minus 3 mole per liter. That is molar. So the concentration of OH minus ion in the system will be 10 raised to power minus 3 molar. So from this, we can find out the concentration of H plus ions. We have this equation H plus into OH minus as 10 to the power minus 14. So from this we can find out the concentration of H plus ions. And if we know the concentration of H plus ions, then minus negative logarithm of H plus ions will give me pH as 11. Is it clear, Saket? Anyone else?
So 17 gram of OH minus ion is equals to 10 to the minus 3 mole. सर
Yes.
सर ये नहीं समझ में आया कैसे आया.
हाँ, सी 1 मोल विल हैव, 1 मोल में 17 ग्राम्स OH माइनस होंगे. ठीक है. ओके.
हम्म,
बट
हम्म,
अब सो 17 मिलीग्राम के लिए हो जाएगा 1/1000 मोल. राइट. Because
ओके
okay,
ओके
1/1000, so 10 to the power minus 3 mole. But if it in terms of in 1 liter solution, so mole per liter will be molar. So that's why 10 to the power minus 3 m, that is molar, like this.
ओके सर.
Okay, so if we know the concentration of OH minus ion, we can find H plus ion and then we'll get the pH. I hope others are also able to catch up with this question. If you have any doubt, you can ask me right now. If you are not reply anything, I will think that you have a clear understanding and we will move on to the next question. Okay. Okay, D'Souza. So we'll move on to the next one. It's a match the following type. So we have to match the column 1 with the column 2 related to the total solids. So we have discussed about various types of solids. So there are some examples in column 2. You have to just match it. D. Okay, this is saying it as D. Anyone else with any other answer? We'll check one by one. I think D is not the correct answer. Please retry. Please think in some other direction because D is not the correct answer.
C.
C. Okay. Okay, so we'll see the answer. So the answer is C is correct. So we'll see one by one. Like we are talking about fixed dissolved solids. So if it is able to dissolve, it will be a salt. Mostly salts are able to dissolve. Okay, and mostly inorganic salts are able to dissolve. And it is fixed so that it can't be evaporated easily. So heavy metals and inorganic salts will include the fixed dissolved solids. Then we have volatile dissolved solids. So if it is a volatile matter, then it must be an organic type. Okay, and it is able to dissolve. So it can be a type like sugar or fatty acids. So these are organic, plus they can be dissolved, and at higher temperature they are able to be evaporated. So they are volatile. So B with go with 1. And then we have fixed suspended solids. So if we talk about suspended solids, these are undissolved particles. Okay, suspended solids are undissolved, and silt also. So these will not dissolve easily, and they will not be able to volatilize. So it will be a fixed suspended solids. And at last we have the microorganisms. Microorganisms are organic, plus they are able to volatilize at higher temperatures. So these are volatile suspended solids. Okay, I hope I am clear with this. So with this approach, we can do the matching in this question. The next question, again, though it looks a very big question, it's pretty simple. So we have 100 milliliter of water, which is filtered through a filter paper of weight 3.5 grams, and the filtrate, which is coming out from the filter paper, is collected in a crucible. Okay, and then it is oven dried at 104 degrees Celsius for 24 hours, and the resulting weight of the filter is 3.65 grams, and the dried weight of crucible was 33.6 grams. So assuming there is no weight loss of the filter paper or the crucible during the heating, so what would be the total suspended solids? So here we are asking about the total suspended solids concentration. So first of all, tell me, for total suspended solids or suspended solids, do we consider the filtrate part or the part which is on the filter paper? Which part we have to see? If we are talking about suspended solids, we will check for the filtrate or the filter paper, which has been captured by the filter paper. Are you able to get my question? Filter paper, okay, because the suspended solids will not be able to filter through the paper. So we will see the particles which are on the filter paper. Okay, so now try to solve. We have the initial weight and the final weight.
1500 milligram per liter.
1500 milligram per liter. Okay, it is the correct answer. 1500 milligram per liter. So we know the mass of the filter paper, that is initial mass is 3.5, and after oven drying the volatile solids will be removed. So the the filter paper with the sample will be having 3.65 grams, and hence 3.65 minus 3.5 will be have 0.15 gram of the suspended solids, and it is in 100 ml of solution. So 0.15 divided by 100 will give me 100 into 1000 will give me 1500 milligram per liter. I hope it's clear for everyone, because if in 100 ml we have 0.15 grams, so in 1 liter we will have 1.5 grams, and which is equal to 1500 milligrams. So it is 1500 milligram per liter. Okay. So the next question is a continuation of the previous question. So here we are asking what is the total dissolved solids. Okay, I will go back to the previous slide. You have to calculate the total dissolved solid. Okay, so again, please don't tell me the suspended solids because it already has been discussed. Tell me what is the total dissolved solid. So the filter paper will have the suspended solids, whereas the dissolved solids will filter through the paper and will be collected in the crucible. So just see the weights of the crucible and tell me the answer.
21,000 milligram per liter.
21,000 milligram per liter. Okay, so we will see. Okay, the correct answer is 21,000. Pretty simple. So the final weight is 33.6. Initial weight was 31.5. So 2.1 divided by 100 into 1000. It is 21,000 milligram per liter. Okay, another question. Just listen to the question carefully. A sample has a pH of 9. 200 ml of water require 1.1 ml of 0.02 normal H2SO4 to titrate it to phenolphthalein endpoint, and 22.9 ml of H2SO4 is required to titrate it to further methyl orange endpoint. So what is the total and the carbonate alkalinity? You have to find the total and the carbonate alkalinity. And now we have to find these alkalinities in terms of mg per liter as CaCO3. So as I think someone was asking, like how do we express it in terms of CaCO3? You will see in this question, like how alkalinity will be expressed in terms of calcium carbonate. So to reach the phenolphthalein endpoint, we will need 1.1 ml of acid, and to reach to methyl orange endpoint, we need another 22.9 ml of acid. So we have to find the alkalinity. We know alkalinity is acid neutralizing capacity. If you are not able to solve this question, please let me know. I will teach you how to do. It's just that you have to play with the units. It's a very straightforward question. You just have to play with the units. And you should know like what is carbonate alkalinity and what is the total alkalinity. Should I move forward?
Sorry, sir.
Okay, so the correct answer is C, but we'll see how it comes. So first of all, we'll see how to calculate the carbonate alkalinity. So carbonate alkalinity is still the phenolphthalein endpoint. So we need know that we need 1.1 ml of this uh, 1.1 ml of acid. So and the strength of acid is 0.02 normal, which is, and normality we calculate in terms of equivalent per liter. So we have 1.1 ml of acid into its strength, that is 0.02 normal, that is equivalent per liter in 200 ml of water. So this much is understood. And now this this we will give in terms of equivalent per liter. This ml and ml will get cancelled, and we will get the carbonate alkalinity in terms of equivalent per liter. Okay, so now we have to change it into milligram per liter as CaCO3. So we know if we check the molecular weight of CaCO3, it will be 100. Okay, 40 plus 12 plus 48, it will be 100. If 100 is the molecular weight, the charge is 2, or the combining capacity is 2, so the equivalent weight will be 50 gram per equivalent. Okay, so if it is 50 gram per equivalent, then in terms of milligram, it will be 50,000 milligram per equivalent. So from here it comes as 50,000 milligram per equivalent. So I will tell it uh, once more. We know the molecular weight of CaCO3 as 100. The combining capacity of CaCO3 is 2. So the equivalent weight of CaCO3 will be 100 by 2, which is 50. 50 gram per equivalent. Okay. And if you want to convert into milligram per equivalent, it will be 50 into 1000, that is 50,000 milligram per equivalent. So if we calculate 1.1 into 0.02 divided by 200 into 50,000, we will get 5.5 milligram per liter as CaCO3. Am I clear? Please let me know if you have any problem understanding this question. If you want, I can go through it once more. Any reaction, emojis? Okay. Saket, is it clear?
No, sir.
No. What is the problem? Where are you facing the problem? You can be frank, you can speak in Hindi, no problem.
Sir, is it the formula of carbonate alkalinity?
No, this is, you don't see the formula. See, for getting the carbonate alkalinity, we have to see what is my phenolphthalein endpoint. So how much ml of acid is required to reach the phenolphthalein endpoint. Okay, so it is given that 1.1 ml is required. But alkalinity cannot be 1.1 ml. So from ml we have to change the unit. Okay, so we have 1.1 ml, and the strength of acid is 0.02 normal. So normality means equivalents per liter. Okay, you might have learned in basic chemistry, normality is equivalent per liter. As molarity is moles per liter, normality is equivalent per liter. So 1.1 into 0.02 equivalent per liter is the total amount of acid required in 200 milligram of water, because the total sample volume is 200. So we have to divide by the sample volume. Okay, so if we do just this part, we will get the answer as equivalent per liter. Okay, are you able to understand? Hello, Saket?
Yes, sir.
Ha. So we'll get the answer in terms of equivalents per liter. But I am asking the answer in terms of milligram per liter as CaCO3. So we have to multiply with another factor, which is in terms of CaCO3. So we know for CaCO3, the molecular weight is 100, okay, and the combining capacity is 2 for CaCO3. So the equivalent per liter of CaCO3 will be 100 by 2, that is 50. So it is, and it is grams per equivalent. So if you want to change it to milligram per equivalent, we will multiply with another 1000. So it will become 50,000, like that. I hope it is. Now we'll see the next one. Okay. So the next one talks about the total alkalinity. So for total alkalinity, we require 1.1 ml, which is for till you reach the phenolphthalein endpoint, plus another 22.9 ml. So everything remains the same, but only the total volume of acid changes. So we have 1.1 plus 22.9. Rest all things will be same because these are just for the conversion of the unit. Okay, so like this way we will calculate the carbonate and the total alkalinity. I hope it is clear.
Okay, sir.
Okay, if you have any issues later also, you can reach out to me on mail. I will send you some more questions or some more explanation regarding this. You will get my email ID. You just write it to me. I will provide you
Okay, sir.
more uh, material on this. Okay, or we will have another discussion on this. That is not an issue. I just don't have the pen right now. Maybe in the next class I can explain if you remind me. Okay. So this is the 16th question. Okay. So the next question is a wastewater sample of 3 ml is made up to 300 ml of BOD bottle. The initial DO was 7.5 and after 5 days it becomes 0 milligram per liter. So what is this BOD? We have done a similar question. It is also pretty simple. Just calculate and tell. Or what is the answer for BOD?
750.
750. Anyone else who thinks it's at 750? Please, it's a very simple question. If you see, see 750. Okay, so most of you are saying it as 750. Okay, tell me. So the initial DO was 7.5, and after 5 days, we have seen that the DO becomes 0. So what is basically BOD? BOD is the amount of oxygen required to decompose the biodegradable organic matter present in the system. Okay, so to degrade the biodegradable organic matter, we need oxygen, which is the dissolved oxygen. So we have seen on day 1 it is 7.5, and after 5 days again we are calculating, it becomes 0. So within 5 days we have used up the total 7.5 milligram per liter of dissolved oxygen. Okay, what if the dissolved oxygen has been finished on fourth day itself or third day itself? Then how we will know that it is the actual BOD of the system? Suppose the system is very polluted, it has lots of organic matter, but the DO is less. It might have required some 10 milligram per liter. Okay, but you have provided only 7.5 milligram per liter. So the 7.5 milligram per liter will be finished in 5 days. Definitely it would be finished. But my system required 10 milligram per liter. So will it give any true picture of the system? Are you able to get it? If the DO is going to 0 milligram per liter at the end of 5 days, then we don't know the actual picture of the system because all the DO is exhausted. Okay, so in these cases, we cannot calculate the BOD. It is not possible. Is it clear? So the answer would be none of the above because we cannot calculate the DO of the BOD of the system because all the dissolved oxygen has been finished within 5 days, and the there are there may be more organic matter is present in the system and it may require more dissolved oxygen. So we cannot say like how much actually is required for biodegrading the organic matter. Are you able to follow? Anyone? Or should I explain it in some other way? Please be
Please
fast.
explain once again.
हाँ, okay, I will discuss in हिंदी. Okay, for your sake. सोचो तुम्हारे सिस्टम में 10 मिलीग्राम, तुम्हारे सिस्टम को मतलब जो भी तुम्हारा वेस्ट है या ऑर्गेनिक मैटर है उसको 10 मिलीग्राम पर लीटर ऑफ ऑक्सीजन चाहिए था. ठीक है, तुम्हें नहीं पता. लेट्स इमेजिन उसको चाहिए 10 मिलीग्राम पर लीटर, बट तुमने सिस्टम में दिया बस 7.5 मिलीग्राम पर लीटर. तो ऑब्वियसली 5 दिन में वो तो खत्म ही हो जाएगा, वो जीरो हो जाएगा. सिस्टम पूरा मतलब माइक्रो ऑर्गेनिजम्स पूरा 7.5 मिलीग्राम पर लीटर ऑफ ऑक्सीजन खत्म ही कर देगी. बट तुम्हारे सिस्टम को तो और 2.5 चाहिए था ना, बट तुमको तो वो पता ही नहीं चला क्योंकि तुम्हारा डीओ जीरो हो गया 5वें दिन के एंड में. अगर तुमने सपोज करो 11 प्रोवाइड किया होता या 12 डीओ प्रोवाइड किया होता तो 12 से वो 2 पे आ गया होता, तो तुम श्योर हो जाते कि हाँ अभी भी 2 बचा हुआ है, इसका मतलब उन्होंने 10 मिलीग्राम पर लीटर ही यूज किया है डिजॉल्व ऑक्सीजन. तो इसका मतलब मेरे सिस्टम का बीओडी 10 मिलीग्राम पर लीटर के हिसाब से मैं कैलकुलेट करूंगा. ओके साकेत, इज इट क्लियर फॉर यू?
Yes, sir.
Okay, okay, Bala, let me again explain in English. Suppose your system requires 10 milligram per liter of dissolved oxygen. Okay, but you have provided only 7.5 milligram of dissolved oxygen. So in 5 days, definitely your 7.5 milligram of dissolved oxygen will get finished, right? Because your system requires 10 milligram per liter of dissolved oxygen. So how will you come to know like what is the actual BOD of the system if the dissolved oxygen is getting fully finished? There is no way. You cannot predict. Suppose you have provided 12 milligram of dissolved oxygen and it reduced to 2 because your system required 10. So from 12 it reduced to 2. So now you can say, okay, my system has reduced from 12 to 2. So that means 10 milligram of dissolved oxygen is required. But if it has reduced to zero, then you cannot know, right? Like how much extra would have been required to degrade the organic matter. So whenever there is a case that the fifth day BOD becomes zero, we cannot calculate the BOD of the system.
So it means we have required both readings.
Yes, we need both the readings. There should be a reading for initial also, and there should be a reading for final also. Then only we are pretty much sure that the system requires this much of DO. If it is becoming zero, we don't know how much extra it would have required. Okay, so in general, there should the fifth day BOD should be at least equal to 1 milligram per liter. If it is going below 1 milligram per liter, then that means there is some problem with your experiment. You have to repeat your experiment with some other dilution. You have to dilute the wastewater more such that the final reading is more than 1 milligram per liter.
Yes, that is clear.
Okay, So this is what I wanted to convey. So whenever the fifth day BOD goes below 1 milligram per liter, that means you have to repeat your experiment. Okay, you cannot trust your experiment. You have to repeat your experiments with some more dilution of the wastewater. If you're diluting the wastewater, then the requirement of DO would be less, so the final DO would be higher. So in that way you can know, and with the help of dilution factor you will get the same BOD. Okay, so this is, though this question looked exactly similar to the previous question, but here we cannot calculate the BOD. Okay, okay, so the next question. Total alkalinity present in the water sample is 205 milligram per liter as CaCO3. If the non-carbonate hardness present in the sample is 63 milligram per liter as CaCO3, determine the total hardness and carbonate hardness. And we have to ignore the alkalinity due to OH minus ion. Suppose there is no OH minus ion alkalinity present in the system. It is all carbonate and bicarbonate. So tell me what is the total hardness and the carbonate hardness. These are a little tricky questions, but it would definitely help you to understand. Yeah, D'Souza, you asked a very genuine question. Suppose it requires exactly 7.5 milligram per liter, but we still are not sure because it has reduced to zero. It might be requiring only 7.5 milligram per liter, but then again, we cannot trust the experiment. So you have to repeat the experiment, change the dilution so that your final DO reading is more than one, and then you can trust the experiment and you can find out the value. Okay, yeah. Fine. So the question is the total alkalinity is 205, the non-carbonate hardness is 63. We have to find the total hardness and the carbonate hardness. Okay, I will go through the solution. The correct answer is A, but doesn't matter. We see how it comes. So suppose in the system I have said that there is some non-carbonate hardness already present. So if non-carbonate hardness is already present in the system, then by default, the carbonate hardness will be equal to the total alkalinity. So how it comes, I will explain. We know that alkalinity is given by carbonate, bicarbonate, and OH minus ions. Okay, alkalinity is the combination of carbonate, bicarbonate, and OH minus ions. But here I have already told you that there is no OH minus ions. So the alkalinity will be because of the carbonate and the bicarbonate. Okay, so if the alkalinity is only due to the carbonate and the bicarbonate, it will be equal to my total carbonate hardness, because we know carbonate hardness is due to carbonate and bicarbonate. So in this aspect, my carbonate hardness will be equal to total alkalinity. I hope it is clear. I will explain once more. The total alkalinity is due to carbonate, bicarbonate and OH minus ions. Okay, but here I have told you that there is no OH minus ions. So my total alkalinity is due to carbonate and the bicarbonate. Again, my carbonate hardness is also carbonate and bicarbonate. So my carbonate hardness will be equal to total alkalinity. So we know the total alkalinity is 205. So my carbonate hardness will be also equal to 205. And what is total hardness? Total hardness is carbonate hardness plus non-carbonate hardness. We know carbonate hardness as 205 and the non-carbonate hardness as 63. So my total hardness would be 205 plus 63, that is 268. So the correct answer is A. Total hardness as 268, carbonate hardness as 205. Is it clear? There is no calculation required. It's a direct concept. If you know the concept, you can solve the answer, solve the question. Please give me some reaction if it's okay.
Okay, sir.
Okay, fine. Okay, so the next question is now calculate the alkalinity in terms of milligram per liter as CaCO3 for 1 liter of sample which contains 0.35 grams of HCO3 minus, 0.12 grams of CO32 minus, and zero point 0.5 grams of Cl minus ions. So we have to calculate alkalinity in 1 liter of sample which contains HCO3 minus, CO32 minus, and Cl minus, bicarbonate, carbonate, and chloride. We have to find the alkalinity. Just remember, we are calculating alkalinity here. Whenever I am showing the detailed solution, you can take a screenshot. You can go through the question once again. Try to understand. If you have any queries regarding these questions, you can get back to me on my mail, or you can ask me in the next class. Okay. I hope these are little tricky questions for you, but these are very interesting questions and required for the subject. Okay, so we'll see the solution. I think we're waiting for that. So the correct answer is 487. We'll see how it comes. So here I have prepared a table which have the constituents, the concentration, and then I have changed the concentration as milligram per liter as CaCO3 as I've done before. So my bicarbonate concentration is 350. So if I, and it is in terms of milligram per liter. Okay, because 0.35 grams will be equal to 350 milligram, and in 1 liter solution it will be 350 milligram per liter. So my bicarbonate will be 350 milligram per liter. But now I want to change it to milligram per liter as CaCO3 in terms of CaCO3. So again, there is, we have to multiply with a factor. So the factor would be 350 into 50. So what is 50? 50 is the equivalent weight of calcium carbonate. And what is 61? 61 is the equivalent weight of bicarbonate. So how 61 is the equivalent weight of bicarbonate? So if we see the molecular weight of bicarbonate, it is 1 plus 12 plus 3 into 16, which is equal to 61. And it has a charge of -1 or 1. So 61 by 1 is 61. So the equivalent weight of bicarbonate is 61, and the equivalent weight of calcium carbonate, as I've discussed before, it is 100 by 2 because both Ca2 plus and CO3 2 minus have 2 charge. So it will be 100 by 2 is equal to 50. So if you want to convert the concentration of bicarbonate into milligram per liter as CaCO3, so we will take the concentration, multiply with the equivalent weight of calcium carbonate, and then divide with the equivalent weight of bicarbonate. Okay, so it will give me 287. Now then, for carbonate, again same, the concentration is 120, which is equal to 0.12 into 1000. Okay, so we get the result in terms of milligram per liter. Now again, we will see how to change it to in terms of CaCO3. It will be 120 into 50, which is the equivalent weight of calcium carbonate, divided by the equivalent weight of carbonate. So we know carbonate molecular weight is 12 plus 16 into 3, that is 60. So 60 is the molecular weight. For equivalent weight, we have to divide with the charge. So the charge of of CO3 2 minus is 2. So 60 by 2, it becomes 30. Is it clear? Anyone is having any doubt in the conversion of milligram per liter to milligram per liter as CaCO3? We just have
50 is the equivalent weight.
50 is the equivalent weight of calcium carbonate. Okay. So in this question, we will not consider the chloride in the calculation because chloride will not impart any alkalinity. So the total alkalinity will be 287 plus 200, that will be equal to my 487. I
Okay, sir.
hope, okay. I hope it is clear for others also. Okay. So the last question, it's again very simple question. A water sample contains 375 milligram per liter of phenol and 150 milligram per liter of dextrose. What is the ultimate BOD? So we have phenol and dextrose into the system. So can someone tell me what is the formula for phenol? In simple terms, you can Google it. C6H5OH, yes. So it is C6H5OH. So try to make a balanced equation with C6H5OH plus oxygen, which will give you CO2 plus H2. Yes, Bala is the same, C6H6O or C6H5OH, both are same. Uh, so I will quickly go through this. So how many oxygen molecules are required for the balanced equation? Has anybody done? C6H6O plus X moles of O2 will give me Y moles of CO2 plus Z moles of H2O. So what is X? My oxygen. And what is dextrose? What is dextrose? Formula? A form of sugar, yes. So is glucose and dextrose the same thing? I hope you might have seen the formula. Yes, it is also C6H12O6. Both glucose and dextrose have the same formula, but glucose is generally found, a type of sugar which is generally found in blood in humans, and whereas Dextrose is a type of sugar that is found in food. Okay, so this is the basic difference between dextrose and glucose. But for our purpose, both are same because both formula is same. So we'll quickly go through the solution for this. So the answer is 1054 milligram per liter. So we have C6H6O, which will require 7 moles of oxygen. So 94 gram of phenol will require 224 gram of oxygen if we see the molecular weight of both the things. So 375 milligram per liter of glucose will require 894 milligram of oxygen. So the BOD for phenol is 894, whereas for dextrose it is same as glucose. 180 requires 192 gram of oxygen, and if we calculate for 150 milligram of dextrose, it would be 160. So 894 plus 160 will give me 1054 milligram per liter. So I hope it's clear for everyone. Do you have any doubt? If you have any queries regarding any of the previous question, you can ask me now, because these are the 20 questions which I had. If you have any, yes, Saket?
Okay, sir. No problem.
Okay, no problem. Okay, MPN problem. NPN problem, I don't have it right now, but just wait for 1 minute. So NPN problem, maybe I can uh, provide you some sample problems if you want. Just if you have any query, just drop in your email ID in the chat box. I will send.
एमपीएन टेबल सर लर्न करनी पड़ेगी.
No, no, there is no need to memorize the NPN table. No, not at all. It is required. Okay, it is not at all required. Uh, in if in exam it is asked, they will provide you the table, or it is asked, or it will be asked just for assignments where you have the access for the tables. There is no need to learn the table. It's a pretty big table. So what we generally do in NPN test is like we have a 10 ml sample test tube, we have a 1 ml sample test tube, and we have a 0.1 ml sample test tube. Okay, and we have 5 uh, duplicates, like we have 5 10 ml, 5 1 ml, and 5.1 ml sample test tubes. And we will, after our experiment, we will see in how many test tubes we have gas evolved. Okay, so we will count the number of test tubes. So suppose I get a combination of 5 4 3. That means for 10 ml samples I have all the samples which have the hydro, like which have the gas. In 1 ml samples I have 4 of them, and in point 0.1 of 0.1 ml of sample I have 3 of them. So in this way I will get a sequence as 5 4 3. Okay, so with this sequence I will just see my MPN table, like how much corresponding MPN number is coming from the table. So if it is 543, I will see, suppose it is 20, so my MPN will be 20. So it is pretty simple. You don't have to memorize anything. You just have to see the sequence, like out of 5, how many uh, things are having the gas evolved. Okay, so you have dropped all your email IDs. Okay, so I will try to send you some of the problems. And suppose you have diluted the samples, then again you have to multiply with the dilution factor. So both the types of problem I will send you by tonight. I will try to send you by tonight so that you are able to solve the assignments. And if you have any problem with those questions, you can reply to me back. Okay, anything else? Any other request? Okay, so this PPT you won't be able to get, but you can this video, like whatever we have discussed, it will be recorded in YouTube. So in YouTube, you can just type in my name, Akash Shaha NPTL. So by tomorrow, you will be able to access this video in my YouTube channel. So you just write Akash Saha NPTL in YouTube, and you will be able to access this video. Yeah, sure. So if late joiners, if you have missed any of the questions, you can see it in my YouTube channel, or you can write back to me at saha19akash@gmail.com. This is my personal email ID, so I will be able to reply you in this. And we will have our next class on 22nd of August at same time, 7 to 9, and we will discuss all the concept, not the concept, but more with practicing the problems and other numericals. We will discuss the concepts and we will solve a few questions. Okay, so I hope it's clear for everyone. Anything else? I'll wait for 5 more minutes here. If you have any queries, you can ask me now, or you can log out from the system, from this meeting. I'll be here for 5 more minutes if you want to ask me anything. Thank you, Kirti. Thank you, Aditya and Bala. Also, if you have any queries regarding any of the wastewater treatment systems or water design, water treatment system design, and anything related to environmental engineering, you can write it to me. If possible, I will help you. Okay.
सर एक
Yes.
लेक्चर में थ्योरेटिकल थ्योरी डिस्कस की गई थी,
Okay.
तो सर ने इक्वेशन लिखी थी K C8H5O4 प्लस 7.5
हाँ हाँ
O2।
हाँ, समझ गया, मैं समझ गया, बताओ।
सर इसमें सर एक्स वाई जेड मान करके किया गया था, इसका सॉल्व किया था क्वेश्चन को।
हाँ 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 हाँ।
सर वो मेथड नहीं समझ में आई थी एक बार।
सी, तुम उसकी चिंता मत करो। वो तुमको मेथड लगाने की कोई ज़रूरत नहीं है। हमने जैसे क्वेश्चन सॉल्व किए थे, वो एक एम्पेरिकल मेथड है। उसमें ऐसे जैसे C6H12O6 तुम्हारे पास ग्लूकोज है, तो उसमें एक्स वाई जेड हो जाएगा 6 12 6। सी का जो 6 है वो एक्स हो जाएगा, एच का जो 12 है वो वाई हो जाएगा, और ओ का जो 6 है वो जेड हो जाएगा। तो अगर तुम एक्स वाई जेड का वैल्यू उस इक्वेशन में डाल दोगे, तो तुमको डायरेक्टली सीयूडी का वैल्यू मिल जाएगा। समझ गए?
यस सर।
ओके। सो जरूरी नहीं है, डोंट नो नीड टू रिमेम्बर द फॉर्मूला। जैसे हम करते आए हैं, तुम इक्वेशन लिखो, उसको बैलेंस करो, यू विल नो हाउ मच of oxygen will be required, how much is the molecular weight of my organic matter. You will be able to calculate it directly, जैसे हमने ग्लूकोज के लिए किया, डेक्सट्रॉस के लिए किया, फिनॉल के लिए किया। ठीक है, तो इक्वेशन लिखो, उसको बैलेंस करो, इजी तरीका है। तुम अगर एक्स वाई जेड के टर्म्स में उसे याद करने जाओगे तो उसमें टाइम लग जाएगा। ठीक है। सो दोनों मेथड कर सकते हो। अगर तुम याद कर सकते हो तो याद कर लो, वरना तुम इक्वेशन सॉल्व करके भी क्वेश्चन कर सकते
Yes, sir, it is clear.
हो। ओके,
Thank you, sir.
नो प्रॉब्लम, थैंक। Supraja and Bala, do you have any question? If you don't have any question, you can leave the meeting.
Sir,
Yes, yes, tell me.
uh,
Hello, are you saying something?
hello.
Yeah, tell me.
By by attending these sessions, we can write the assignments well, sir.
Okay, thank you very much.
No, sir. I am asking that by listening these sessions, we can write the assignments well, sir.
Yeah, because this will help you to develop the concepts, and most of the questions are in line with the assignments. So, if you attend the sessions regularly, it will be helpful for you.
Okay, sir. Sir, first session videos, uh, madam said, sir.
Now, first session videos, sorry.
Madam, I don't know name of that madam, sir.
See, we have
Like
like she's another assistant for this course. So I have my regular classes every Tuesday from 7 to 9.
no, sir. Live sessions recording only that madams one are coming, sir. That's why I'm asking.
No, live service. No, if you go down in that file, Excel file, you will get my link also. In the first table, it is her YouTube ID or her YouTube channel's links will be there. If you go down in this on the Excel sheet, you will get the links for my recordings also. Okay.
Okay, sir. Thank you, sir.
Okay. You can leave the session if you have if you don't have any.
Sir,
Bolo Saket.
how can we calculate total alkalinity and total acidity?
Total alkalinity and total acidity. See,
Yes, sir.
depends that it will depend like what datas are given in the question. Okay, so you know the total alkalinity will be due to the bicarbonate plus 2 times of your carbonate plus OH minus ions minus the H plus ion concentration. So if you have these details, you can directly put in and you can find out whether it is in terms of milligram per liter or it is in terms of milligram per liter or as CaCO3. So alkalinity will be HCO3 minus plus 2CO3 2 minus plus OH minus minus H plus concentration. Okay, and similarly acidity will be the other things. H2CO3 plus HCO3 plus H plus minus OH minus. Okay, if you see the slides, you will get these equations. It is there. So you have to calculate in terms of milligram per liter और जैसा मैंने बाकी क्वेश्चन सॉल्व किया था, तुमको कॉन्सेंट्रेशन निकालना है मिलीग्राम पर लीटर के टर्म्स में या मिलीग्राम पर लीटर एज CaCO3 के टर्म्स में, फिर उसको ऐड करना है।